Heartfelt gratitude to Dr.V.Sampath Kumar for accepting the invitation and presiding over this event. I did like to give a warm welcome to everyone who is attending the 1 week FDP on recent trends of material technology. With great pleasure, I introduce our distinguished guest, Dr. V. Sampath Kumar, Assistant Professor, Department of Civil Engineering, Kongu Engineering College, Tamil Nadu. He received a first-class distinction in his Bachelor's of Engineering in Civil Engineering from Arod Senthur Engineering College in Perundurai. He is a master degree holder in engineering with a focus on environmental engineering. He achieved the 23rd university rank in the Anna University examination during his bachelor degree. He has 9 years of teaching experience in total. He has published over 20 research publications in prestigious journals and over 30 papers at national and international conferences in the field of civil engineering. He organized more than 10 workshops, seminars, and conferences. He is a member of Institute of Civil Engineering. He supervised more than 15 BTech and MTech student projects. Now I would like to invite our esteemed chief guest to take over this session.
Good morning, Rami ma'am. Yeah, thank you all. Good morning to honorable person over here. So first of all, I would like to thank Sanskrithi School of Engineering, the principal, the management, and the HOD, civil HOD, the Ramya ma'am, so for giving me the opportunity to participate in this faculty development program. All of you able to see my presentation, Ramya ma'am? Yeah, okay, thank you. So today I'm going to discuss about the topic development of agro-based biomass briquettes from sorghum, panicle, and pear millet. So it is purely based on the waste from wealth. So from the not only in agricultural waste, I am focusing here as an agricultural waste. So the main theme of this topic is the waste to wealth. So the overview of the presentation. So introduction, literature study, so problem identification and objectives, methodology, materials and methods, physical properties, proximate analysis, EDAX analysis, scanning electron microscope analysis, thermogravimetric analysis, differential scanning calorimetry analysis, so results and discussion, and comparison analysis, industrial application, so scope for the future work, conclusion and reference. Okay. So before we are going to start an main part of the topic, so we have to give some, I have to give some introduction about this topic. Okay. So the developed and developing countries like US, China, UK, and some European countries, they did lot of researches related to renewable energy, but they have failed to convert that research into industrialization. So that is the biggest problem we are facing currently. We are the world facing for energy demand. So we daily are seeing the news channels. Every time all the countries and in all the states in our country also, all the states are facing the electricity problems and the energy demands. Industries are also facing the energy problem. So here I am made an attempting the biomass from the agricultural waste. So we know the biomass is the third largest primary energy source after the using of coal and petroleum products. Okay, so the world's 14% of the populations, they are using biomass as a main energy source for their energy utilization. So the farmers, they are knowing and unknowingly, they are knowing or unknowingly, they are burning that agricultural waste as in open burning, so which causes the environmental problems, and that releases the greenhouse gas and ozone layer depletion, and it also creates the air pollution. So it is necessary to use them in an effective and environmental friendly manner. So the only way, the waste we have to convert into product. So here is the attempt made that agricultural waste, the conversion of agricultural waste into briquette fuel, solid biomass briquette fuel, has been found to be safe and less harmful comparing to the coal usage and petroleum product usage. The solid biomass briquette is a very less harmful emission when compared to the other energy generations. Okay, so here the literature review, why we are taking the literature review means, so from this literature, from suppose I am doing some research related to biomass or some material or some say environmental sustainability or water and wastewater treatment. So before, the lot of researchers they have studied, they have used different materials and different technologies, and they have used some different results for their particular area. So that's why I am taking some literatures related to this study. So the Lee et al. 2021. So the Lee et al. They are using the materials rice husk, eucalyptus wood, and binder, concentrated grape with hydraulic press method. And Trubetskaya in the year 2019, they are used wood chips in roller press type. Okay, so the main studies involved in this literatures, the mechanical properties, physical properties, biological properties, thermogravimetric analysis, and what type of binders they are using, what type of mixed ratios they are taken, and what are the mechanisms they are using, like that we have to infer from this literature. So main inference from the literature I have referred, different composition of biomass sold different physical and chemical properties. Okay, we know, okay. So the different composition of biomass sold different physical and chemical properties, and different mix ratio of the briquette sold different physical chemical properties. And during the mixing of waste material, one or two materials or more than two materials, binders plays a vital role in the quality of the briquettes. So binder is the important material that have to bind the board more than one or two materials. Okay, so the different binders also produce a different quality of briquettes. And in this literature, I have referred the main thing, that is the densification of the briquettes plays an essential role in the handling ability and transportability of the briquettes from one place to another place. So without proper densification, it is not able to transfer from the briquette, produced biomass briquettes from one place to another place. Okay, so the process parameters like moisture content, density, compaction pressure, mixer ratio, they are playing an important role in the quality of the briquettes. Okay, so the problem identifications. Okay, we know the why we are taking this type of research, why we are going to do some research in that particular area. It means depending upon the problems only we have to do research. Okay, so the burning of agrarian waste has become a major problem in India. So for example, Delhi air pollution. Okay, so it is difficult to the farmers to clear the agricultural waste and to prepare the soil for the next immediate harvest. Okay, so they are ready to immediate harvest. It means they are knowing or unknowingly they are burning their agricultural waste. So it will create a lot of consequences to the environments. Okay, so farmers burn the farm waste to clear the land without noticing environmental consequences. So to fix this issue, government has come up with different policies. So here, educating new technologies to farmers will help them to earn even from the waste and add value to the agricultural waste by providing the good revenue outputs. Since India is an agriculture country, million tons of agricultural waste left over every year. So efficient use of this waste will enable us to safeguard our environment and to self-sufficient in fuel energy. So this image shows the open burning of agricultural waste. So not only we are burning the agricultural waste in our country, so we are burning the solid waste, we are burning our individual home cotton waste, and industries, they are burning their own outlets. These are all the creating more problem, more air pollution and temperature increasing in our country, and it is also change the climate. It is also playing an important role to change to change the climatic conditions. Okay, so according to the recent survey, it has been estimated that the burning of the agricultural waste residue releases about 149.24 million tons of carbon dioxide, 9 million tons of carbon monoxide, and 1.28 million tons of particulate matter, 0.25 million tons of sulfur, and 0.07 million tons of black carbon during the burning of only in the agricultural waste in our country. So it also the responsible for the cause of haze in Delhi, and it is also melts the glaciers of Himalaya. So while I am studying in my schoolings, okay, I was heard about from my teachers the Himalayan is increased. Himalayan height is increased every year. So, but we are hearing about that Himalayan country, Himalayan mountain, Himalayan. So we are knowing about it was decreased it was the height of the Himalayan decreased by every year. So it is the main reason for burning not only in agricultural waste, open burning of all the type of waste will increases temperature. So during the temperature increases, it means on the Himalayan height is also decreased. Okay, so one of the major causes of air pollution in Delhi is the burning of stubble, mainly in northwest India, such as Punjab and Haryana, since in the year 2002. So the burning of these waste produces smoke, which reaches the atmosphere and causes the cloud of particles, which is even visible, and it is even visible and mixing in the air. So it also the main reason to increasing the temperature from 38.2 degrees Celsius to 42.2 degrees Celsius. So nearly 1 degree Celsius, to nearly 4 degrees Celsius increasing while burning the agricultural waste. Okay, so on it also we are burning that agricultural waste in our agricultural land. It also kills the microorganisms and group of fungi present in the soil. So nearly 1 centimeter depth of temperature penetrate to the soil, so that soil kills all the microorganisms present in that soil. So we have to avoid open burning of the agricultural waste. This is the main problem identified in our country. Okay, so then the open burning of the burning of coal in industries. So by the utilization of coal in thermal power plants, electricity is generated. We all know. Okay, so but it has its own disadvantages, such as greenhouse gas emissions, destruction of mines, generation of million tons of waste, and emission of harmful substances. So the greenhouse gas emission from the imported coal was found to be 1.129 gram of CO2 for the generation of electricity. So the thermal power plant which runs coal releases harmful substances into the environment, and some of the harmful substances are mercury, arsenic, sulfur dioxide, carbon monoxide, and selenium. These harmful substances enter to the atmosphere and also cause the acid rain. So the coal burning is mainly caused air pollution and also acid rain. So the generation of fly ash from burning of coal. So we have to, after using the coal in thermal power plant, we are stored the generated fly ash in landfilling. Okay, so open it, we have stored that generated fly ash in dry condition and is also in wet conditions. From the survey, it was found that the fly ash generated annually from the power plants has been raised from 123 million tons to 226 million tons in the year 1920, which is about, comparing to the previous year, 76% increased. So as the rainwater percolates into the dry form, it carries all the pollutants such as heavy metals into the groundwater, and it is also polluted to the lakes, ponds, and also groundwater. So this also may cause health effect from human beings who live nearby the mining surroundings. So deforestation. So we all know the mainly this research and this topic is mainly focused to replace the country wood using in the brick kilns, hotels, and other industrial boiler running purpose. Okay, so they increase the level of carbon dioxide in the atmosphere, which is greenhouse gas, and leads to the global warming while we are doing the deforestation. So it also leads to the limited supply of wood and timber. It also leads to the soil erosion. So objectives of this study: to investigate the biomass made of different composition for its characteristics, to optimize briquettes, to study the quality of bio-briquettes for the effect of its different combinations of agro waste with the binder, and to study the results obtained from the physical characteristics, PROXIMATE analysis, SEM analysis, elemental analysis, DSC and TGA analysis, and the industrial applications for different fraction of mixes in the biomass briquette. To compare the results obtained from the physical characteristics, proximate analysis, elemental analysis, same TGA, DSC, and heating value with the results of other agricultural briquettes with different compositions. So the methodology, okay. So before we are going to start this research or start this this work, we have to frame a methodology. What we are going to in this research, okay. So because mainly we are focusing in suppose we have to take in civil engineering, we are having different stream. So concrete technology, structural engineering, each department having different stream. So I'm taking here as a civil engineering department. So environmental engineering, concrete technology, steel, and remote sensing engines, construction management, like that. So from that, which type of stream we have to take, we have to finalize. So here I'm taking as an environmental engineering. So in that environmental engineering, different areas are there: energy, water and wastewater treatment, and carbon footprint, climatic conditions, so environmental sustainability, various parts are there. So from that, I have to taken from waste to wealth, that is the energy conversion from the waste. Okay. So after finalizing the stream and area, I have to taken the next level as a problem identification. So I'm mainly focusing which type of problem I am focusing. Okay. So after the focusing the problem or after defining the problem, I have taken some literature ready. Previous study, some experts did their research related to that particular study. It means I have inference from lot of information from that literature study. So after the literature study, after the information gave from the previous experts research, I have taken the next step as a material selection. So from my area or from my locality, so what type of waste, agricultural waste mostly generated, and how that waste focusing, how that waste causing the environmental pollution, like that I have taken the material. After taking that material, initially it was allowed for sun drying, then cleaning, screening, grinding and various mixed proportions, and starch preparation and hydraulic press system. After sun drying the particular material, it was allowed for physical characteristics that are height or thickness, diameter, color, texture, density, relaxation density, Saturn index, density ratio, and relaxation ratio. After involving in the physical properties, it is allowed for physical analysis, proximate analysis, moisture content, volatile matter, ash content, fixed carbon and lignocellulosic level. After the proximate analysis, EDAX and SEM analysis, it was analyzed. EDAX is used to find out the micro and macro elements present in that particular produced biomass briquettes, and the SEM analysis is used to find out the structural morphology of the produced biomass briquettes. So TGA and DSA analysis. TGA analysis is used to find out the residual mass, how much percentage of residual mass left over the burning of that particular produced solid biomass briquette. And DSA analysis is used to find out the high heating value and peak temperature, endothermic reaction and exothermic reaction, mass reduction phase, decomposition phase, and loss of sample mass. So after all the initial characteristics is after find out the initial characteristics of the produced biomass briquettes, it is allowed for the compression strength test. So the briquette formation, peak load, breaking time, pressure, elongation, and compression strength. Why we are studying that compression strength? It means we have to find out the strength of the produced biomass briquettes. Then only it is able to transport from one place to another place, and it is able to store a long time. Here I am taken the materials, 3 different materials, one for sorghum, panicle, and pear millet, that is used to produce the solid biomass briquette, and cassava starch is used as a binder. It is purchased from the industry. Okay, so before suppose we are collecting the material, so the agro waste material, sorghum, panicle, and pear millet, and suppose we are preparing the cassava starch. It means we are going to do some feedstock pre-processing, that are cleaning, drying, and size reduction. So cleaning, it means it is also simply called as sieving, which is done to remove all unwanted materials, ensuring that all the feedstock of the required size. We have to remove unwanted material present in the collected biomass materials. That means in sorghum, panicle, and pear millets. So next one is drying. So drying is essential, particularly if the feed is wet. Suppose we are collecting that sorghum, panicle, and pear millet is in wet condition. It means we have to allow that collected biomass material, agricultural waste materials in a sun drying. Okay, some materials like coffee husk, groundnut shell, and rice husk usually may not require drying. Okay, So these are the sorghum panicles and corn stalk and sunflower waste. PM millet is supposed in wet condition, it means definitely we are allowing that particular material in a sun drying. Okay, so according to the Solana et al. 2018, drying can be done naturally by exposing the feedstock to favorable environmental conditions to reduce its moisture content. So without supplying any external heat. Suppose we are giving any external heat for drying that particular waste material, means definitely it will deploy the condensed present in the particular waste materials. Okay. So next one is the size reduction. Size reduction of the biomass was reduced less than 2.36 mm. So as per the Capello et al. 2020. So size reduction is also one of the very important process prior biomass briquetting. Okay, size reduction in biomass also increases the bulk density. So the low size reduction, it means the size reduction varies from maximum 80 mm. We have to take according to the UNEP 2011. So here I'm taking 2.36 mm. So because the low, I mean the less size of the less size of the collected agro-waste material, it will give the high density. So this image shows the produced biomass briquette is grinded and sieving, and it is allowed for natural drying of the agro waste materials. So next one, binder preparation. So here I am using the cassava starch is used for a binder for the production of agricultural waste briquettes. Okay, so the less than 0.5 mm is mixed with then 150 ml of distilled water made to dissolve. So while preparing this cassava starch binder, proper care should be taken at this stage so far avoiding the formation of clogs and lumps. Okay, so the formed binder solution is heated in a water bath of 100 degrees Celsius for 10 to 15 minutes as per Sen et al. 2016. This mixture is continuously stirred until a whole paste is formed. It means the semi-solid formation. So in the process of the briquette production, the starch is added to the sample with a concentration of 10% of the weight. Here, the produced biomass briquettes or take and the binder solution added as a 10% of the weight. Okay, so why I am choosing that cassava starch as a binder, it means it has a superior quality and higher physical and mechanical dealing while mixing with the 2 or more agro waste materials. So this image shows the first image shows the cassava starch powder, and second image shows the produced cassava starch binder solution. So after setting all the initial things, that means the agricultural waste material collected and initial pre-stock processing are completed, and the starch solution are also prepared, and sun drying and grinding, all the things are completed. So after all the basic things, we are going to prepare a briquette mold. So here taken as a cylindrical briquette mold was used, having an inner diameter of 80 mm. So 3 parts are here. So first the top portion is a soft, then center portion is a mold, and bottom portion is a steel plate. Okay, so the cylindrical mold was the dia of the cylindrical mold as 80 mm, the thickness of the mold is 8 mm, and the height of the mold was 150 mm. The compaction piston was used, having its diameter of 76 mm, height of 175 mm, and it has total weight of 10 kg. The steel plate in bottom portion, okay, the steel plate was found attached to the edge of the base and is firmly tightened. The molded briquette was evacuated by expelling the plate from the base edge. The hydraulic press was used to production of the biomass briquette for getting the uniform size of the solid biomass briquette. This is the machine we are having in our structural engineering laboratory in our Kongu Engineering College. So this machine name is called the Control Universal Testing Machine. The making model of TUF Servo 1000 with the maximum load of 1000 kilonewton. It is illustrated in this image. Okay, here the maximum load 1000 kilonewton. Here I was set as a constant load of 200 kilonewton is maintained throughout the experiment. So the dwelling time of each press was sustained at 60 seconds, attained constant sorghum panicle and PM millet briquette in all the given samples. So mixed ratio of loose biomass. So here I am taken sorghum panicle and PM millet, and binder ratio has 10% weight. So the two constant concrete, I mean concrete solid BioBriquette produced, that is 100:0. That means 100% of sorghum panicle and 0% of PM millet, and 100% of PM millet, 0% of sorghum panicle. So the remaining briquettes were produced under various blended proportions, such as 10:90, 20:80, 30:70, 40:60, 50:50, 60:40, and inversely it is mixed, both the sorghum panicle and PM millet. So the various proportions of sorghum panicle PM millet samples were applied for the production of briquettes with different peak load. So this image shows the produced agro biomass briquettes with various mix ratios. So 10:0:100, 10:90, 20:80, 30:70, up to 100:0. So there are 11 solid biomass briquettes are produced in this shown in this image. Okay. So while producing, so here attain different peak load levels. So here we are set as constant load of 200 kilonewton, but here we are getting different peak load levels. From the sample S1 to S11 it varied. From the sample S1 having 186.440 kilonewton, so the minimum peak load was attained 186.44 kilonewton for the sample S1, S6, S7 and S8, and the maximum peak load was attained the sample S10, S9:0. Why? Suppose we are know why these different peak load? Because the reason for the variation was that the particle size of the PM millet. Okay, so we have taken two materials here, sorghum panicle and PM millet. The particle size of the PM millet was finer than the sorghum panicle. So the spaces between the sorghum panicle particles were closely filled the finer particles of PM millets. So this is the reason we are getting the different peak load levels during the production of the agro biomass briquettes. So this image shows the peak load graph for sample S11. It is 0% sorghum panicle and 100% PM millet, and 60:40, 60% of sorghum panicle and 40% of PM millet for the sample S7. So while coming the resultant discussion, the produced briquettes were tested for its physical characteristics, proximate analysis, compression strength test, EDAX analysis, SEM analysis, TGA DSC analysis, industrial application and comparison analysis. Okay, so while we are initially we are discussing about the physical characteristics of produced biomass briquette. All the produced biomass briquettes were initially analyzed based on the ASTM standards, American Standard Testing Methods standards we are using. So the physical properties of the produced briquettes in this study limited to diameter, height, thickness, mass of the produced biomass briquettes, volume, density, mass in relaxed stage, relaxed density, density ratio, relaxation ratio, standard index, texture and color. So these are all the different physical properties we are analyzed. So the briquettes before in previous image we have seen. Okay, so this image shows the briquette shows rough in texture and brown in color. Okay, brown in color. So the diameter of the produced biomass briquette was found to be 80 mm because the mold dia, the cylindrical mold dia is 80 mm. So the produced biomass briquette is also having 80 mm dia for all the proportions of the samples. The thickness of the sample ranged between 55 mm to 65 mm. So the thickness ranged between these ranges between 55 to 65 mm is main reason for the voids present in the particular mixed proportions. Okay. So from the results obtained, it was found that the maximum volume of 326.67 meter cube was obtained in the sample S4, and sample S11 attained the minimum value of 276.46 meter cube. Okay. So this image shows the different density of the briquettes from the sample S4 having minimum density value, that is 624.95 meter cube, and sample S10 having maximum density value 773.71 kilogram per meter cube. So the compressed density of sorghum panicle and PM millet briquettes ranges from 624.95 kilogram per meter cube and to 773.71 kilogram per meter cube. So it satisfies the minimum value. So definitely the density value required 600 kilogram per meter cube, recommended by Money et al. 2006 for efficient transportation and safe storage. The particle size of the raw materials is another consideration to impacts of density, because less dia or less size of the agricultural waste particles is given high density. Okay, so mass in relaxed stage. Okay, those table shows the various samples having various mass in relaxed stage. The sample S1 and S1 to S11 having very different mass and relaxed stage, mass stage. So the the sample S6 having less mass relaxation stage in that is 197.86 gram for the sample ratio 50:50, and sample S10 having 208.14 gram for the sample ratio 90:10. So the relaxed density of the sorghum panicle PM millet briquettes here shown as the minimum value achieved the sample S4 as 608.44 kilogram per meter cube, and the maximum value of the relaxed density achieved the sample S10 as 740.34 kilogram per meter cube. So here this table shows the density ratio, relaxation ratio, and standard index. Density ratio is also varied from 0.950 to 0.981 because less than 1 density ratio is opt as a good quality briquette. Here all the produced biomass briquette are facing less than 1. Okay, so the relaxation ratio definitely it will greater than 1 is also indicating the good quality briquette. Here we are achieving all the produced biomass briquette of relaxation ratio more than 1. So the minimum value achieved here as 1.09 for the sample S1, their ratio 100:0, and the maximum value achieved for the sample 1.052 for the ratio 40:60 for the sample S5. Here the Saturn index, the briquette Saturn index was determined according to ASTM 86 for the drop Saturn developed for the coal using the different for the equation. The Saturn index is equal to weight of the briquette retained on the screen after dropping. So we are dropping that briquette from 1 to 1.5 meter height. So 1 every time. So we have to drop that produced biomass briquette in 3 times. We have to note the value of the weight of the particular dropped briquette. We have to note it at that particular weight. Okay. So weight of divided by weight of the briquette before dropping. Okay. So we have to weight before dropping of the produced biomass briquette, and after 3 times we are dropping. In each time we are dropping the produced biomass briquette weight also we have to note it. So the greater than 90 is achieved as a good quality Saturn index produced biomass briquettes. Here all the produced biomass briquette having more than 95. So the minimum value was achieved for the sample S8 with their mixed ratio of 70:30. Their Saturn index 96.57 and 97.87 as a maximum Saturn index for the sample S2. So the next one is the proximate analysis. So in this produced biomass briquette, we have taken all the produced biomass briquette for their proximate analysis as per ASTM standard. Moisture content ASTM D317387 and fixed D2015-85, and volatile matter ASTM D317589 and ash current ASTM D3174. So this table shows, okay, this table shows the proximate analysis of the produced biomass briquette for the current of ash, current of moisture, and volatile matter content and fixed carbon. So here the ash content values range from 3.01 to 11.60, and moisture content is ranged from 4.21 to 6.900. Okay, so the volatile matter is also ranged from 70.77 to 80.520, and fixed carbon values is also ranged from 10.66 to 13.01 for the sample S7. So the moisture content ranged between we know the 4.21% to 7.38% for the minimum sample S7 and the maximum sample S5. So the results obtained was agreed with the study Pallavi et al. 2013, which suggested that the moisture content 5% to 10% proved as a good quality briquette. And as content, the minimum value achieved 3.01% and maximum value achieved 11.60 for the sample S7. The ash content of the other mixing ratios was found to be within the acceptable limit that ranges between 5 to 40 weight percentage. Here we are getting only 3.12, maximum value 11.60% for the solid biomass briquette as per the United National Environmental Protection Agency 2014. Okay, so the volatile matter and fixed carbon ranges is also varied. So in fact, the high volatile matter with low fixed carbon content is an indication of the readiness of the fuel sample to ignite as per according to Liu et al. 2008. So compressive strength test. So here the same produced equipment was used to find out the compression strength testing. That is the machine name is controlled universal testing machine. the making model TOXI Servo 1000, and is also the working principle as per the British Standard 1610 Part 1 1992 and Indian Standard 1828 Part 1 1991. This test was used to determine the stability and durability of the briquette. So this image shows the initial the initial setup was made with the control unit testing machine, and load was given. The second image shows the load was given, and the final third image shows the cracks developed in that particular produced biomass briquette. So the compression test analysis of the biomass briquettes shows here the sample of the load withstanding load is varied from sample S1 to S11. The maximum load was achieved sample S9 as 20.74, and the minimum value was achieved the sample as S7. That value is 15.24. So the pressure range is also maintained from 17.42 to 17.47. So the next one is an elemental analysis. The elemental analysis was used EDAX Bruker German Nano Express detector. This elemental analysis is used to carry out the amount of chemicals, that means the micro and macro elements present in the particular biomass briquette. It is also helping to find out in the components and its effects on the environment during combustion. So this table shows the various characteristics, various elemental analysis of the produced biomass briquette. Nearly we have found 14 elementals. Okay, that means carbon, oxygen, potassium, calcium, chloride, sulfur, phosphate, silicon, aluminum, magnesium, copper, iron, zinc, and sodium. So the sample S5 having the minimum carbon, that is 48.06%, and the sample S9 having the maximum value of carbon, that is 55.52%. Okay, so the remaining all, so the second leading value is oxygen, that is 44.30% for sample S5 and 41.94 for the sample S9. So the remaining all the elements, the nearly 12 elements are false under acceptable values. So this image shows the EDAX images of the low and high carbon content. So the same image. So here this image shows the low carbon briquette semi-analysis, medium carbon semi-analysis briquettes, and high carbon semi-analysis briquettes. The figure, okay. So the same image for the low carbon, the sample indicates the presence of carbon particles that are deposited on the surface with distinct ridges. The particles are witnessed to be different shapes and size. So the carbon particles present in the low carbon briquette same image, the deposited carbon particles having different shapes and sizes. So the same image of the medium carbon briquettes is founded that with the distinct ridges and longitudinal cracks. The briquettes are characterized by the deposition of carbon in large and small spherical particles. So the high carbon same image shows the longitudinal high longitudinal cracks, but there is no formation in the ridges is not witnessed. So in the sample of larger lumps of carbon particles distributed overall equally, the substance with ridges in all the samples are the fibers of the sorghum, panicle, and PM millets. So the high carbon briquettes having the good quality same image. Okay, so the TGA analysis. So thermogravimetric analysis is also used with the NED ZSCH STA449F3 model, was used to find out the percentage of loss weight or the residual mass of the briquettes made sorghum, panicle, and PM millet. This instrument, this TGA analysis instrument is also worked with the principles of ASTM D3418. Here, the 11 samples we have taken for, we are produced from the solid biomass waste. Here we are taken only 6 samples for the TGA and DSA analysis. Okay, based on the carbon percentage. Okay, here the sample S1 having high weight loss, that is 28.28%. Their temperature, their burning temperature is 549.9 degrees Celsius. On the sample S9 having 26.07, that is the lowest weight loss percentage for the sample S9 with their mixed ratio 80% of sorghum, panicle, and 20% of PM millet. And their their burning temperature is also 547.9 degrees Celsius. So this image shows the TGA and DSA image, the TGA thermogravimetric analysis of the sample S1 and S9. So the reduction in the mass of the sample was observed below. Here, the sample starting with 100%, okay, 100%, the reduction in the mass loss of the sample was observed below 100 degrees Celsius, okay, in this portion from the 100 to 90. So this reduction has happened to the residual moisture loss, okay. So that's why it was from 100 to 90. So there is no decomposition, okay. There is no decomposition of the sample. That the curve was linear from the temperature that is ranged between 100 to 200 degrees Celsius. Okay, from this 100 degrees to 200 degrees Celsius, there is no decomposition. There is no deviation in the TGA curve. So, okay, so between the temperature 240 to 330 degrees Celsius. So here we have to take assumption 240 degrees Celsius to 330 degrees Celsius. There is a single stage decomposition is observed. It is mainly due to the reduction of mass of the sample is observed. Okay, so the main thing, this was single stage reduction is being carbon is converted into carbon dioxide and carbon monoxide. So the loss of the mass of the sample gets gradually reduced due to the reduction of the composition of the combustible substances. So the weight loss was found to be 28.28% from this sample. Okay, 28.28% at the temperature of 547.9 degrees Celsius, which is mainly due to the presence of non-combustible substances and ash. Okay. So the next one is the differential scanning calorimetry analysis. Here the same sample S9 80:20 and the sample S3 20:80. So the minimum peak value achieved the sample S3 as 340.7 degrees Celsius, and the maximum heating value was achieved the sample S9 as 342.6 degrees Celsius. So the differential calorimetric analysis was used with the same TGA analysis instrument. It is used to find out the heating value of the produced biomass briquettes. And here the reaction starts with exothermic and endothermic. Both the reactions are applied here. So formed here, that is an exothermic and endothermic reaction. But initially it was started with exothermic and it is suddenly down to the endothermic reaction. The temperature for both the figure 89.36 degrees Celsius to 76 degrees Celsius. So the initial sudden exothermic to endothermic reaction is happened. The main reason is the sudden moisture loss of the produced biomass briquette. So the reaction becomes exothermic from the temperature 225 degrees Celsius for the samples S9 and S1, S9 and S3 due to the let out the energy of combustion of the organic matter. So the distinct peaks were attained at the temperature 342.6 degrees Celsius and 340.7 degrees Celsius. The DSC curve was associated to the combustion of sorghum panicle PML because certainly the exothermic peaks were achieved as the results releasing the energy by the decomposition of fixed carbon and residual lignin. So the next one is an industrial application. So the produced biomass briquettes are involved in for industrial application for the two companies, that is Perundurai Common Effluent Treatment Plant and Shakti 19 Private Limited is located in nearby in our college. These two companies are located in Sipcot Industrial Estate, Perundurai, Tamil Nadu. Okay, so the results from the Perundurai Common Effluent Treatment Plant showed that the briquettes with 80% of sorghum panicle and 20% of pyramid satisfies the requirement of the relevant activities of the combustion heat, total moisture, and ash content. They also certified that with the slight or no modifications, the briquette can be effectively used as a fuel energy source in the treatment plants for their boiler running purpose. Okay, so the briquette tested from the Shakti 19 Limited showed that the combustion of 40% of sorghum panicle and 60% of pyramid, and so it is a good combustion with minimum ash, and is a 40 to 60% of biomass briquette, and 80 to 20% of biomass briquette as a good combustion with minimum ash. Okay, so they are also certified that the combination of briquette can be efficiently used as fuel energy source for industrial in future. Okay, so this image shows the kiln furnace of the industry in Sipcot area. So while burning the produced biomass briquette in the particular industries. So the comparative analysis of the physical characteristics of briquette, here various materials they are using. Already previous study that indicates the various materials they are used with various particle sizes. So the particle sizes ranges from 0.425 mm to 10 mm. Here we are taken less than 2.6 mm. So the diameter is also varied from 24 mm to 96 mm. So the height of the briquette also varied from 8 to 9 mm to 210 mm. So here they are using to production of production of biomass briquette with various technology, that is hydraulic press system, cylindrical die system, and vibratory block mold system. Okay, so the density is also varied from 580. So here I only mentioned 0.58, 580 kilogram per meter cube to 1100 meter cube kilogram per meter cube. So here the produced biomass briquette satisfies the 716.68 kilogram per meter cube. So the most of the studies they are not following the Saturn index the Saturn index value. The value they are taken sawdust and neem as per Rogers Srinivasan et al. 2016. Their Saturn index value is 75%. But here we are produced sorghum panicle PM millet briquette having 97.25%. Okay, so the compression strength is also varied from 4 megapascal to 20.74 megapascal. So the comparative study of the proximate analysis of the biomass briquette. So the proximate analysis, it indicates the moisture content, gas content, fixed carbon and volatile matter. The sodium panicle PM millet briquettes is compared with various biomass briquettes. Okay, so that is the pumpkin salt, flushing, soybean waste, rices, water hyacinth, wheat straw, mango leaves, buggies and coal, corn cob, coffee husk, hurricane leaves, rices can wood chips, bottom leaves, sorghum panicle and pyramid is my study. Okay, so the moisture content is also varied from 3.76% to 18.20%. So the our study indicates is the 4.315%, and the gas content is also indicates 0.69% to 24.43%, and fixed carbon is also indicates 5.7% to 73.04%. So the volatile matter is also varied from all the produced biomass briquettes. So the produced sorghum panicle and PM briquettes satisfies all the proximate analysis. Okay, the comparative study of elemental analysis. The major elements are COX, NOx, oxide. That means carbon, oxygen, hydrogen, and nitrogen and sulfur. The carbon is the leading value for all the produced biomass briquette compared to the previous studies in the palm kernels, soybean means, mango leaves, rices, fruits, coffee husk, sawdust,
ಇನ್ನೂ ಒಂದೆರಡು ದಿವಸ ನೀರಿದೆ ಎಲ್ಲ ಕಿತ್ಬಿಟ್ಟಿದ್ದಾರೆ ದಾರ ಕಟ್ಟಿಲ್ಲ ಇಲ್ಲ ಹಾಕೊಳ್ಳಿ ಮನೆ ಹತ್ರ ಎಲ್ಲ ಹಾಕ್ತೀರಾ ಕಟ್ಕೊಡಿ.
Okay, so the carbon values also varied. Carbon is the leading value, oxygen is the second leading value. So the hydrogen, nitrogen, and sulfur is the minimum value we have attained from all the produced biomass briquette. The produced biomass briquette is our sorghum panicle and pyramid is also satisfies the elemental characteristics. Okay, so the thermogrammetric analysis, all the produced biomass briquettes are compared with the various biomass briquettes. So with the different TGA analyzer with the different atmosphere, so nitrogen atmosphere. Some of the equipments are in oxygen atmosphere, some of the equipments in both the nitrogen and oxygen atmosphere. So here we are using the nitrogen atmosphere produced biomass briquettes, where the weight loss of varied from 8% to 34.68%. So here the produced biomass briquette having 27.93%. So the comparative study of differential scanning calorimetry and DSC analysis. So the rices chore as a Mighty et al. 2006 they did, and coffee, spent coffee ground, Epsules et al. 2020 they using they are getting the reaction exothermic. But our study having both exothermic and endothermic, and but the Nutzel and Brand, Trubetskoy, D. Oliveira Mayo, and Tabakov they are studied with their material with the combination of exothermic and endothermic reaction. So here the conclusion. The study has incided the handling factors such as density. The high density value is 773.71 kilogram per meter cube for the sample S10, and the relaxed density is also for the same sample we are having. So the density is main indication to transport the material, produced biomass briquette from one place to another place. The maximum density ratio was achieved from the sample S10 is 0.986, and the relaxation ratio was achieved the sample S10 as 1.047. The maximum Saturn index was achieved as a 97.87% for the sample S2, and the proximate analysis least moisture content was achieved for the sample S7 and S9 as 4.21% and 4.315%, and high volatile matter was achieved for the sample S1 as 80.52% and S11 as 79.62%, and minimum percentage of asconate was achieved the sample S1 as 3.01% and S11 as 3.6%. And fixed carbon is also achieved for the sample S7 as 13.01% and S1 as 10.66%. So the EDAX analysis, the elemental analysis also indicates the macro and micro elements. The carbon is a leading value and oxygen is a second leading value. Potassium is also found in that particular produced biomass briquette. So in addition to that, from few of samples, SOx and NOx were found in small traces, and hence it is proved that the fuel considered for the environmental friendly. And it is also while using these type of agricultural waste, agricultural waste solid biomass briquette, it is also reduced the air pollution in the atmosphere. So the results of SEM analysis have revealed that the sorghum panicle PM liquid were rough in texture, and deposition of larger lumps and small spherical particles are spread over there. The carbon particles were present on the surface in few of the sorghum panicle and PM briquettes. So the TGA curve is also used to find out the weight loss, and the initial weight loss was achieved less than 100 degrees Celsius because of moisture content, reduction of moisture content, and 240 to 350 degrees Celsius. It was observed the pyrolysis of hemicellulose and lignin in the initial stages, and third part of the decomposition was occurred in the sample in the temperature of 350 degrees Celsius during the decomposition of complex lignin. So the differential scanning calorimetry analysis, the maximum peak curve was obtained from the sample S1, X6, S9 as 345.2 degrees Celsius, 342.9 degrees Celsius, and 342.6 degrees Celsius. Additionally, the maximum gloss transition temperature was observed the sample S3 S2 for 24.9 degrees Celsius and sample S11 S2 20.9 degrees Celsius. So from compression strength, we have achieved, we have got the maximum withstand load as 20.74 kN for the sample S9, and for the sample S7 as minimum withstand load as 15.24 kN. So by comparing the sorghum panicle pyramidal briquettes for various samples, banana leaves, sorghum leaves, groundnut cells, coffee husk, sawdust, neem, rices, soda weed, mango leaves, it was confirmed that the material chosen has proven as optimal results than other biomass briquettes. So from the certifications of the Perundurai Common Effluent Treatment Plant and Shakti 19 Private Limited, it was evident that the briquette combination of 80% and sorghum panicle of 20% of pear millet could be effectively used in industrial and domestic applications. So these are all some of the publications I have published that particular study. So in environmental science and pollution research, the macro technology, recent technology and engineering with Scopus Index Journal, and International Journal of Emerging Trends and Technology is also Scopus Index journals. These are some of the reference I have taken for my this study. So thank you.
Good morning to all. If you have any doubts, you can ask to chief guest. No doubts? Shall we wind up, sir?
Yeah, there is no queries means we will end up the session.
Okay, sir. Okay, sir. Thank you, sir. Thank you, sir. It's give me an immense pleasure to deliver the vote of thanks for this event to all dignitaries assembled here. I would like to thank our chief guest who honored this program with inspirational thoughts and good ideas. I would like to thank our beloved principal sir, staff members, participants for making this program grand success. Thank you, sir.
Okay, thank you, Ananda. Thanks for giving me the opportunity.
Thank you.
Yeah, thank you, ma'am. Thank you.
the filter is not working. Just now only I opened.